वालेकुम।
Thank you, Beta. Any questions about the course from the last lecture? Any comments? जी बेटा बताइए। डबल ए
सर मैंने कोर्स लेट एनरोल किया था। कैन यू सेंड द स्लैक लिंक अगेन बिकॉज आई डिडंट गेट इट।
जी जी आप जाएंगे ना एलएमएस के ऊपर, तो जो एलएमएस का मेन पेज है उसके ऊपर लिंक अवेलेबल है। मैंने वहां पर सब कुछ पोस्ट कर दिया हुआ है, जूम का लिंक भी और स्लैक का लिंक भी और कोर्स पेज का लिंक भी।
ओके सर, थैंक यू।
ठीक है बेटा, लेकिन मैं आपको ईमेल भी कर दूंगा। ठीक है, एनी अदर क्वेश्चंस?
सर वो लाइक यू सेड के बाद में वो एसिंक्रोनस हो जाएगा, सो डज दैट मीन कि लाइव लेक्चर्स नहीं होंगे लाइक इसके बाद?
लाइव लेक्चर्स, लाइव सेशंस होंगे, लेकिन कंटेंट के लिए यू विल हैव प्री रिकॉर्डेड वीडियोस। हम ट्यूसडे थर्सडे दोनों सेशंस के अंदर मिला करेंगे, एंड on Tuesday session I will respond to the questions you have about the content. On Thursday we will have a tutorial in which I will review the material and I will solve some problems, formulation of machine learning problems, some numerical problems, or some Python related issues. तो उसको हम थर्सडे को इशू एड्रेस किया करेंगे। और थर्सडे क्लास के एंड के ऊपर हर वीक में क्विज होगा जो कि उस वीक के कंटेंट के ऊपर होगा। उसका आइडिया ये है कि आप साथ साथ कैचअप करते रहे मटेरियल को।
ठीक है सर, थैंक यू सो मच।
ठीक है बेटा। So there's a question. So what was model validation in the block diagram, right? Okay. So usually when you train your model and you say your model is ready for prediction tasks or classification tasks, there is a need to validate a model, right? And we do validation in two ways. Validation on the validation data or the validation on the testing data. उसके बारे में हम आज बात करेंगे, लेकिन I can give you an overview. So the idea is there's a possibility that your model is working very well on the training data, and it may not gives you a good result on the data that model has not seen before. And therefore there is a need to validate a model to make sure the model is generalized enough so that it can make predictions for an unseen data in future, or the model is useful enough. So model validation is to generalize, to ensure that the model is generalized enough. ठीक है बेटा? Okay. Thank you Taha for sharing the link.
एक्सक्यूज मी सर।
जी बेटा।
सर इस केस में अगर हमारा जो मॉडल है वो ट्रेनिंग डेटा के ऊपर ठीक चलता है और एक्चुअल डेटा पे नहीं सही चलता, सो लाइक व्हाट एल्स कैन वी डू, बिकॉज़ हमारे पास तो फिर लाइक कोई और अदर वे अराउंड है टू इंप्रूव द मॉडल, लाइक फिर क्या होता है?
जी जी, जब हम उसको ट्रेन कर रहे होते हैं we make sure that we split it into two parts, training and testing. हम ट्रेनिंग पे डेटा पे ट्रेन करते हैं और टेस्टिंग पे उसकी परफॉर्मेंस को एवेलुएट करते हैं। सो दिस इज समथिंग सिमिलर के द मॉडल इज बीइंग एवेलुएटेड ऑन डेटा that is not seen before by the model. उसके बारे में बात करेंगे। We'll talk about this in today's lecture in more detail. ठीक है, और उसको मैथमेटिकली देखेंगे। So what do we mean by all of this?
सर एक क्वेश्चन था, हम किसी भी मॉडल को देख के कह सकते हैं कि हमें मतलब कितना ट्रेनिंग डेटा रिक्वायर्ड होगा इस मॉडल के लिए, या कितना चाहिए होगा?
कितना ट्रेनिंग डेटा होगा?
या इट टोटली डिपेंड्स ऑन, मतलब डेटा किस तरह का है, किस तरह के फैक्टर से हम कह सकते हैं कि
आई वुड आंसर, मैं इसको दोनों तरीके से जवाब दूंगा आपको। Obviously it depends on the nature of the problem कि उसमें variability कितनी है, right? और आप डेटा कैप्चर किया है, उस डेटा की जो डिस्ट्रीब्यूशन है वो कितनी यूनिफॉर्म है, क्या वो पूरी पॉपुलेशन कैप्चर करी है कि नहीं कर रही है. और आपने क्वेश्चन पूछा मॉडल को देख के हम बता सकते हैं. Let's suppose model is linear, right? So you only have a couple of parameters to learn, right? It means if your data is a true representative of the distribution, you only need few data points to learn a model. Right? So learning is a combination of the nature of your sample, the nature of your model, and the algorithm you use for learning.
Okay.
ठीक है.
ठीक है, thank you.
ठीक है बेटा. Okay. So any other questions before we start?
Sir, what do we mean by data? Data mean pictures?
Data means pictures, data means time series, data means some numerical values, or it could be a categorical value, say gender क्या है, हम उसके बारे में बात करेंगे आज, right? कि data क्या होता है, features क्या होते हैं, और labels क्या होते हैं, ठीक है? Okay. चलिए मेरे ख्याल हम स्टार्ट करते हैं जी. So in today's lecture we will talk about supervised learning setup. I assume you can see my screen. So we will talk about what is supervised learning, what do we mean by regression classification, although in the first lecture we talked about this briefly, but today we will move forward and build on those concepts. And then I will also talk about what do we mean by data, features, labels, training data, testing data, what do we mean by the notion of learning in machine learning, learning se murad kya hai. And finally, we will conclude the lecture with this train, test, split concept, that why do we split data into training data, testing data, and validation data. Okay, moving forward. So this is the slide from the last lecture. So what is machine learning? Machine learning is, so given examples, given the data, we want to use an algorithms. We want to write an algorithm to train a model, right? So finally, we are after a model which we can use to carry out predictions or classification or clustering in future. So there are two things here. One is algorithm and one is model. And I would like to clarify the difference between these two. That okay, algorithm or model में difference क्या है? Right? At times we feel that the students are confusing algorithm क्या और model क्या है. Right? I talked about this in the last lecture as well. An algorithm is a procedure, is a method, is a technique that you run on data to create a machine learning model. Right? And model could be a linear regression, a bunch of coefficients, जो कि बता रहे हैं, मॉडल बता रहा है कि आपने डेटा को इनपुट्स को कैसे मैनिपुलेट करने हैं आउटपुट के लिए और आउटपुट फाइंड करने के लिए. Right? So model is a mathematical or a structural representation of the manipulation of the data to find an output. Right? अगर मैं इसको थोड़ा सा explain करूं with some examples. So let's suppose we are doing linear regression. So we run linear regression algorithm to produce a model which is just a vector of values of the coefficients of the model. So आपका model क्या है? So model is saying कि आप inputs का, so you sum your inputs and you get an output. You get a weighted sum of inputs and you get an output. But the question is, what are the weights should we use for a model? A model is characterized by those weights, but the way to find those weights using data is an algorithm. So algorithm is a procedure which you run on data to find those weights. And once you find those weights, you can say your model is ready. Okay, ji? Another example could be a decision tree algorithm, right? So a decision tree model is a tree which is a combination of simply if-then statements with some specific values. So we use decision tree algorithm to produce a model, which is a tree, and these if-else statements. So an algorithm you run on the data to produce a model. Another example could be a neural network, right? So we use neural network and we use these two algorithms, gradient descent, इसके बारे में बात करेंगे, and backpropagation, right? So we use these two methods, these two algorithms, these two techniques to produce a model. A model is how do you manipulate, how do you combine inputs, how do you traverse those inputs through a network to obtain an output. So model is weights in the neural network. Ji Munim beta, question aapka?
Sir, I was asking, could you explain what you mean by weighted input? What does it exactly mean when an input is weighted?
Okay, sure. For example, we have two inputs. We have a model. Okay, model is something like this. F of x is a1. So x is a vector. For example, x is in R2. Right? और आप कह सकते हैं कि you want to predict the stock price of some shares given the inflation and given the GDP, right? So you can say x1. So x is a vector belongs to R2. It has two components, x1 and x2. हम इसको mathematically define करते हैं. When x belongs to R2, it has two components, x1 and x2. So x1 is, say, your inflation. X2 is your GDP value, your GDP growth, right? And you say the stock price for some, say, cement industry is related to these two as A1 x1 plus A2 x2 and plus A3. उसको आप A0 भी कह सकते हैं. It's a biased term, right? So ये एक mathematical model है, right? And you know that's how the share price is related to these two. This is our assumption. And now the question is how to find this A1 and A2 and A3 given the data, right? So you use linear regression algorithm you run this algorithm on the data to find A1, A2, and A3. And once you have A1, A2, A3, you say, you know the model, right? You know the relationship between X1, X2, and the output, right? I hope
Understood, sir.
अब clear हो गया होगा इस example से.
Yes, sir.
Okay, great. Okay, so I have explained the difference between algorithm and model, right? Let's talk about supervised learning. So we reviewed this briefly in the last lecture. In supervised learning, we have the training data which is labeled. It means for all the inputs, so we want to learn a model, right, which has a bunch of inputs, right? So it could be x1, x2, and so on and so forth, say d number of inputs, right? And one output. So in the training data, the data is in the form that you know the inputs and you also know for the corresponding inputs the output. And you use this data to learn a model. So the learning algorithm receive a set of inputs with corresponding correct outputs for training of a model. कि आपके पास actual output भी available है data के अंदर, And that's why we call it supervised learning. So this is how a kid learns from its parent, right? The last lecture. So we teach a kid that that's how cat look like. So a parent is teaching a kid, okay, ये features हैं. If you see features, these features, you would classify that as a cat, or with these features you classify this animal or a picture as a dog, right? So that's why we call it supervised learning, because we know the true label for the given inputs. So we categorize supervised learning broadly into two categories: regression and classification. When regression is when we want to train a model, we want to find a model that carries out quantitative prediction, or prediction is on a continuous scale. For example, we want to build a model that can determine age of a person from his or her photo, right? Or say price of a 10 Marla 5-bedroom house in 2050. I think so, the way the real estate is growing, it would be around, I think we cannot predict, it's exponentially increasing. Similarly, USD to PKR exchange rate after 1 week, right? So you want to train a model that can make this prediction. Or efficacy of Pfizer COVID vaccine. Maybe you need 5 boosters, 10 boosters, and boosters. So you want to predict average temperature or rainfall during monsoon. Okay? Or if you want to predict cumulative score in ML course, given the number of hours you spend per week, or the number of books you read, the number of articles you read, the number of videos you watch, given all this data, can we predict cumulative score in the course? Or example could be probability of decrease in the electricity prices in Pakistan, almost zero, but yeah. Number of steps per day we want to predict. So what do all these problems have in common? So the output is continuous in nature, right? So we have continuous outputs. So we can say predicting continuous outputs is called regression. ठीक है जी? Any questions? Any questions? Okay. So I assume now you're clear what do you mean by regression. What's the classification? So given us data sample, we want to predict its class. Examples could be prediction of a gender of a person using photo or handwriting style, right? Spam filtering, whether the email you receive is a spam or not a spam. Okay. Object detection in a photo, right? So we give you a photo and you want to detect whether there's a vehicle in the image or not, whether there's a pedestrian in the image or not, whether there is an accident happening or not. Design.
So can there be more than two possibilities in this case? Like, can there be more than two classes, or like are we restricted to only two classes? Like,
if there are two classes, we call it a binary classification problem. If there are more than two classes, we call it multi-class classification. We can have multiple classes, but if the classes, if the output is discrete in nature, for example, letter grade in ML course. This is, if we're talking about cumulative score in ML course, that is regression. If we're talking about letter grade in ML course, that is classification, right? And this is a multi-class classification.
okay, sir.
Okay, better. Two participants. Okay, let me. जी बेटा कौन है पहले? Zishan जी.
Sir, can you tell how can we observe labeled data through these examples? I cannot understand this.
How can we?
Observe the labeled data, like letter
What
grade
do,
in ML
okay,
course.
what do we mean by label data
Yeah.
here? For example,
Yeah,
let's talk about this example, spam filtering, right? So label data means you will have thousands, say you have 1,000 emails. It means you have the have the content of those emails, and each email someone read the content of the email and label it whether it's a spam or not a spam. कि वो legitimate email थी या spam था, right? So you assign label to every email, right?
yes, okay.
And now this is your label data, right? And now if you get some new email, right? You get an email that is not labeled. So now you need a model that classify this email as spam or not a spam. So you build a model using existing 1,000 emails and learn that if there is a word credit, if there's a word bank, if there's a word say a draw or a lottery, if you expect all these words in one email, so you learn from these 1,000 emails कि अगर इन 1,000 emails के अंदर जो जितनी भी spam वाली हैं उन सब में ये words common है, right? And so you run algorithm to learn this pattern, right? And once you have learned this pattern, what you get is a model. And model is simply it looks for these 4 words in a new email. वो देखेगा कि जो नई email आई उसमें 4 words हैं. If there are 4 words, you would say the email is spam. I hope it is clear now.
Yes.
Okay, great. Okay. So what do all these problems have in common? So the output is discrete. The output is categorical. If we only have yes, no, or for example, in spam filtering, we have yes, no. We have object detection, object hai ya nahi hai. Gender, male, female. We'll back on campus on February 1, or maybe we are back on in-person classes on February 1. Yes, no. These are all binary classification. Letter grade in ML course, as I said earlier, this is a multi-class classification problem. Hamza, ji beta.
Yes, sir. In the second last example, the decrease expected in electricity price. Sir, can you explain how is that discrete?
हम ये नहीं कह रहे कितना decrease होगा, right? That's why in the previous slide, so I talked about probability of decrease, right? So I think मैंने इसको rephrase नहीं किया, right? Whether decrease is expected or not. This is classification. If you're after probability of decrease in electricity prices, that is a regression.
Okay, sir. Thanks.
ठीक है बेटा. Okay, so this is, we can say, predicting a categorical output is called classification. ठीक है जी. Any other questions?
Sir, can you give the multi-class classification example?
जी लेटर ग्रेड इन एमएल कोर्स के अगर आप मुझे बताएं कि आपने पर वीक में एक स्टूडेंट कितना टाइम इस कोर्स के ऊपर लगा रहा है, कितनी बुक्स पढ़ रहा है, कितने आर्टिकल्स पढ़ रहा है, कितनी वीडियोस देख रहा है इस कोर्स से मुतालिक, और एंड इफ यू वांट टू प्रेडिक्ट कि उसका ए आएगा या डी आएगा, तो या दरम्यान में भी आ सकता है, सी भी आ सकता है, राइट? तो दैट इज अ मल्टी क्लास क्लासिफिकेशन.
Excuse me, sir.
or for example, जैसे हमने last time बात की थी, if you give an image of say handwritten digits, आपने 1 दिया, 2 दिया, 3 दिया, और go through a model और बताएं कि उसने ये 1 लिखा हुआ है, 2 लिखा हुआ है, 3 लिखा हुआ है, और optical character recognition OCR जिसे हम कहते हैं, that is a multi-class classification.
Excuse me, sir.
जी बेटा, Zen.
सर अगर मैं इन्हीं क्लासेस को बहुत ज्यादा नंबर में कर दूंगा तो एसेंशियली तो रिलेशन ही बन जाएगी ना, नहीं? लाइक इफ आई एम गेटिंग दिस राइट, लाइक अगर आप 1 2 3 की जगह उसको बोलें कि 1 to 100 उसने बताना है, तो वो फिर एक तरह से डिस्क्रीट रह जाएगी, वो फिर भी डिस्क्रीट ही रहेगी।
हाँ,
या वो
discrete ही रहेगी ना. Continuous means yeah, you are doubly right, it's on a real line.
ठीक है।
ठीक है, और maybe आप उसको real number को करके आप, if you're after 1 to 100, so आप कहें 1 2 3 4 5 600, you may treat it as a regression problem, but regression gives you a continuous output, say 1.1 1.2, and you pass this continuous output through say some float function or a seeding function, or round off कर दें उसको आप, and you make it a natural number. Yeah, in that case,
Okay.
Classification would converge to regression.
Okay, sir.
Chat में let me see. So Talha, so do we tell the system how many classes will there be? Gee, obviously, if we're talking about supervised learning, we have labels assigned to every input. So we tell the number of classes to the system. And Minahil is asking, the model always gives us discrete outputs. There's no way to predict how much the decrease may be to the model. Yes, if you're after how much the decrease, then it's regression. Right? If you're after a continuous, a real quantity, a real number, or a value, that is regression. ठीक है बेटा? Okay. Okay, so this is a first glimpse of or a difference between, explanation of difference between regression and classification. I assume now you have a good understanding. At least you know, you can explain now कि regression क्या है, classification क्या है, और supervised learning क्या होती है. ठीक है जी? Okay. So moving forward, we will talk about some of the nomenclature we use in machine learning. Inputs के मुराद क्या है, outputs से मुराद क्या है. The terms I'm using, training data, test data, loss function, features क्या होते हैं, label क्या होता है. Let's talk about these terms very quickly. So in these regression classification problem, the inputs, input could be say a photo of a person, or it could be a numerical value, number of hours you spent per week for a course. So inputs, they're all in machine learning, we refer to those inputs as features. Right? So inputs and features, we use these terms interchangeably. Output referred to as label. We also refer to as sometimes a gold label or a gold standard, right? Because we know the output for given input, gold label or gold standards. Training data, input output for which the output is known and is used for training a model by machine learning algorithm. So there's a question about the spam filtering. So you have 1,000 emails, and those 1,000 emails, you have labels: spam, non-spam, not spam, non-spam. Every email is labeled. This is an example of our training data, right? Okay, we have a new term here, a loss, which we also call an objective function or a cost function. We will talk about different loss functions shortly, but the idea is this loss function determines how well a trained model approximates the training data, or if you use on testing data. So once you have a model, there should be a mechanism to evaluate the performance of the model. Model kitna acha hai ye? And to evaluate the performance of a model, we use a loss function. It is also referred to as an objective function or a cost function. We call it objective function because once we are using algorithm to train a model, we attempt to minimize this objective function. We want to learn those weights A1, A2, A3 such that your model output is as close as possible to the true label. Okay, participants raising hands. Hamza. Okay, Zain.
So do we need to use the loss function on the training data as well? Because like test करना है हम लोग तो फिर तो like unknown unseen data के ऊपर test करेंगे ना जिसका उसको output नहीं पता.
Yes, very good question. Let me explain. When we're training a model using an algorithm, so algorithm should know how the model is behaving. So during the training process, what algorithm is doing, algorithm is trying to learn those weights such that the model output is as close as possible to the gold standard. And therefore, we need a loss function during training of the model to evaluate, to find the model parameters, those coefficients. And we use this loss function to evaluate the performance of the model on the testing data. So training के अंदर हम use करते हैं model को train करने के लिए. और testing data के अंदर we use to evaluate performance of a model on an unseen data. Okay.
जी sir.
Munim, जी बेटा.
Sir, could you just repeat this last explanation one more time for the loss function used for testing and training?
Good. Sure. Say you have a model. You have input and you have an output. Let's say input is X, output is Y. Okay. And you start with an assumption that Y is equal to f of X. And now you want to find this f of X given this training data, input output. For some X, you know Y, for some X, you know Y. And you want to use this information to find this f of X. Okay. So how do you find this f of X? You assume that you find f of X, that is giving you some Y. You take a difference of that Y with the actual label, the given label, the goal label, to find the difference, to find the loss, to find the error between what is being predicted by your model and what is the actual output. Right? And you find such f, you are after such f for which this error is minimized. So we need loss function. So we minimize loss function, we minimize cost function to find a good f of X. And once you have f of X, then you use testing data to evaluate the performance of the model. And again, you use loss function to quantify the performance of the model. Okay,
Yes, sir. Understood. So it's almost like I've learned this recently, but like a feedback control system. You get like an output, you could check whether it's close to the system's requirements you need, and then you just change the input accordingly.
You don't, yeah, there's a difference here. You don't change.
You don't change the input. Yes, you change the system instead.
System instead, yes. This
Yes,
is the
okay.
fundamental difference.
Understood. Thank you, sir.
Okay, beta. Great.
Excuse me sir.
Saud ji beta. I think Zain 1 minute. Saud,
यस सर, मैंने पूछना था आपसे कि जो कॉस्ट फंक्शन होता है, वी ओनली यूज दैट विद द टेस्ट डेटा, राइट? बिकॉज दैट इज आवर गोल्ड स्टैंडर्ड, एंड लाइक गोल्ड स्टैंडर्ड के बगैर वी कैन नॉट कंप्यूट द कॉस्ट फंक्शन। सो लाइक सिर्फ ट्रेनिंग के वक्त कॉस्ट फंक्शन यूज होता है?
जी, we use for both, right? So during training, आप ट्रेनिंग करेंगे कैसे? आपने f फाइंड करना है ना. Let's suppose I give you, आप कहते हैं, we start with a very simple case, right? You have different candidates of f. You have f1 भी आपके पास, एक f2 भी है और f3 भी है, right? And I ask you, choose the best one. How do you choose the best one? You would find during training, you would pick f1, f2 or f3 that is giving a least error or the less loss. And once you're done with that, right, and then you see कि ये model कितना generalized है, right, for an unseen data, and then you use it on testing data.
ठीक है सर, तो टेस्टिंग के लिए तो ठीक है, तो हम किस तरह हम कॉस्ट फंक्शन कैलकुलेट करते हैं वो तो समझ आती है, बट जनरल डेटा होता है, वहाँ पे हम कॉस्ट फंक्शन कैसे कैलकुलेट करते हैं? लाइक डू वी चेक ईच एंड एवरी आउट? नहीं, लाइक ट्रेनिंग हो गई है, लाइक उसके बाद हम किस तरह चेक करते हैं कॉस्ट फंक्शन को ऑन अनट्रेन डेटा कि ये सही दे रहा है कि नहीं दे रहा?
हम टेस्ट डेटा पे करते हैं, राइट? सो हमने उसको ट्रेन डेटा के ऊपर ट्रेन किया. We have determined these parameters a1, a2 and a3, right? So we know a1, a2, a3. Now we're saying the model is giving a very good error on training data. We have found the parameters for which the loss is minimized on training data. Now someone asked a question, आपका मॉडल कितना अच्छा है, right? क्या आंसर डेटा पे काम करेगा नहीं करेगा? तो आप उसे कहेंगे कि मैंने इसको ट्रेन तो इस पे डेटा पे किया, मैंने इस पे डेटा पे किसी और डेटा के ऊपर मैंने टेस्ट भी किया, और टेस्टिंग के ऊपर भी वी नो द आउटपुट, वी नो द गोल्ड लेवल्स, राइट? सो you tested your model on the data that has not been used in the training process, and you will say कि टेस्टिंग के ऊपर उसकी बहुत शानदार परफॉर्मेंस आ रही है. That's why I'm saying that this model is expected to work on an unseen data.
ओके सर, थैंक यू.
ठीक है बेटा. जैन
सर मुझे समझ नहीं आ रही कि जो डेटा हमने उसको दिया है ट्रेन करने के लिए, वो उस पे भी एरर देगा, मतलब क्यों? जब मैंने मॉडल को बता दिया कि x ये है, उसका आंसर y आता है, तो जब मैं उस पे लॉस फंक्शन रन करूंगा तो वो क्यों मुझे कोई एरर देगा? मैं तो उसको पहले बता चुका हूँ कि x का आंसर y है, मतलब क्यों?
नहीं, y नहीं है, मैंने नहीं बताया, राइट?
जब आप ट्रेन कर रहे थे तो आपने ये नहीं उसको बताया कि x है तो y आना चाहिए?
जी मैंने ट्रेनिंग के दौरान ओके आई नो व्हाट यू आर आस्किंग, लेट मी ट्राई टू एक्सप्लेन, राइट? उसको मैं डिटेल में करेंगे, लेकिन मैं उसको आपको बता देता हूँ, ठीक है? बट दिस इज वेरी इंपॉर्टेंट. लेट्स स्टार्ट विद अ वेरी वेरी सिंपल केस. सो दिस इज the model you want to learn, right? Let's say this is 3x plus 4, a model you want to learn, right? And you observe some data, right? So you collect some data, and let's say data collected you here, something like this. कुछ ऊपर भी points हैं. It means for all these red points, you know x and you know corresponding y. Right? This is your training data. Right? So okay. When I say you want to learn model, it means you want to learn okay, slope 3 है or intercept 4 है. Agree? All agree, right? So our learning is we want to find that what is the slope and what is the intercept. So you start with this assumption. f of x is a1x plus a2, and now you want to find a1 and a2. You find a1 and a2, right? So there could be multiple options, right? Let's say in color is green. So one option could be कि ये लाइन भी हो सकती है, right? So ये लाइन भी हो सकती है, ये लाइन भी हो सकती है, और जो ब्लू वाली वो भी हो सकती है, right? For every green line, right? For every a1 and a2, you choose different, you try different a1, a2, right? And for each a1, a2, you find the loss, you find the loss, you find the loss. वो loss क्या होगा? Okay. For a given a1 and a2, you find f of x, which is y. But you also know कि इस x के corresponding actual y क्या था? The difference between those two, and you sum all the differences. In fact, square of differences, which we call least squares. That's how you find the loss. And you pick that a1 and a2 for which this loss is minimized. Agree?
Yes, sir.
And now you can say, here's my model. So I have determined a1 and a2, and have determined in a way such that the loss is minimized, that this model is giving least square error, least error on the training data. Now your friend asks कि ये model कितना अच्छा है तुम्हारा, right? And what you do is you evaluate the loss on testing data. You say कि मैंने उस डेटा के ऊपर इसको evaluate किया लॉस को जिसको मैंने ट्रेनिंग में यूज ही नहीं किया, मैंने कुछ छुपा के रखा हुआ था, राइट? मैंने उस पर इसको evaluate किया और उस पर भी लॉस बहुत अच्छा आ रहा है, लॉस बहुत कम आ रहा है. And therefore now you can say, okay, this model is general enough, assuming that both testing and training data, they are well representative of the actual population data, और जो unseen data आपको फ्यूचर में मिलेगा उसका एक true representative है. Okay. I think I have tried to explain in a very detailed fashion, लेकिन मेरा ख्याल clear हो गया होगा, लेकिन अभी भी questions हैं तो feel free to ask please. Okay, there's a question from Ali. Can you repeat this? बेटा क्या repeat करना है बताएं Ali? Oh, the green line part, yeah. So we have multiple options, right? We have multiple green lines, right? But the question is, which one is the best? How do you pick the best one? You pick the best, you pick the one that is giving you, that is this actual model. You pick the one for which you find a1 and a2, you pick those a1, a2 for which the error between what is predicted by the green line and what the actual label is minimized. So there's also a question, what we try to manipulate the loss function for training data, how would it affect the model? Also, is loss function approximated by the model itself or not? Let me read again. What we try to manipulate the loss function for training data, how would it affect the model? साजिद आप बोल सकते हैं बेटा, आप मुझे बोल के बताएंगे?
सर अगर हम लॉस फंक्शन को जैसे हम उसमें लीस्ट के डिफरेंस निकाल रहे हैं उसको मैनुअली मैनिपुलेट करके एक उसके लिए हम लॉस फंक्शन वो कैलकुलेट करते हैं और मॉडल को हम उस तरह से अगर हम वो उसको मॉडल बनाते हैं एक और फिर उसको हम टेस्ट डेटा पे रन करते हैं तो वो कैसा इफेक्ट देगा?
जी हम इसी तरह तो जनरलाइज करते हैं ना उसको, आप बिल्कुल सही कह रहे हैं. सो हम ट्रेनिंग डेटा को यूज करके और लॉस फंक्शन को यूज करके मॉडल लर्न करते हैं. और जब मॉडल लर्न हो जाएगा तो अगर वो मॉडल टेस्टिंग डेटा के ऊपर भी परफॉर्मेंस अच्छी दे रहा है, लॉस कम दे रहा है, तो हम कहते हैं कि मॉडल अच्छा है. ठीक है बेटा. जर्श.
सर मैंने पूछना था कि लॉस फंक्शन सिर्फ रिग्रेशन मॉडल्स के लिए ही होते हैं या फिर डिस्क्रीट और क्लासिफिकेशन मॉडल्स के लिए भी हो सकते हैं?
जी दोनों के लिए होते हैं, लेकिन दोनों के लिए डिफरेंट होते हैं, और अभी हम सिर्फ 5 मिनट बाद उनको डिस्कस करेंगे मॉडल्स को।
सर कोई बिल्ट इन मॉडल नहीं है, हम मॉडल बना रहे हैं और उनको टेस्ट कर रहे हैं, यानी हम मॉडल चेक कर रहे हैं अभी तक, क्योंकि हमें आउटपुट भी पता है, इनपुट्स भी पता है, और हमें इसमें कोई करना तो नहीं पड़ रहा बाकी।
नहीं, बहुत कुछ करना पड़ता है। आप मॉडल ट्रेन करना पड़ता है ना। आप देखें, आपके पास मॉडल डिफरेंट टाइप्स के हैं ना। आपने अगर रिग्रेशन भी करनी है तो यू हैव अ डिफरेंट class of models which you can use, and we trained different models and we find the loss for different models and we pick the one for which the loss is minimized. हम बेटा हम अभी इसको ना इसको इनको देखते हैं लॉस फंक्शंस को कि what are the types of loss functions we have. हमजा,
सर मैंने ये पूछना था आपसे कि अगर आपका जो लॉस फंक्शन है वो आपके टेस्ट डाटा पे ही अच्छे अच्छे रिजल्ट्स नहीं देता, तो क्या आप फिर दोबारा उस पर रन करेंगे, मतलब या आप दोबारा ट्रेन करेंगे उसको अपने टेस्ट डाटा के ऊपर, ट्रेनिंग डाटा के ऊपर सॉरी,
then you change the model, right? अगर आप कहेंगे मॉडल अच्छा नहीं है जी, आप ये मॉडल किसी काम का नहीं है, ये मॉडल अंडर फिट हो रहा है या ओवर फिट हो रहा है, इसके बारे में बात करेंगे हम। इन टर्म्स से क्या मुराद है कि मॉडल एक डेटा के ऊपर अच्छा काम कर रहा है लेकिन अनसीन पे अच्छा काम नहीं कर रहा है, इसका मतलब आपने मॉडल अच्छा नहीं चूज नहीं किया शुरू में ट्रेनिंग के दौरान।
अब डिस्कार्ड कर देंगे बेसिकली उसको।
हाँ, we will try something else, yeah, or we'll try to complicate this, overcomplicate the model, or at times we also need to reduce the complexity of the model. ठीक है, okay. मेरे से आगे चलते हैं। Okay, okay, for this example, let me again explain, using this example, explain what do we mean by features, labels, and training data. Right? So for example, we have this example, we have interest rate and we have unemployment rate. Obviously, interest rate is not Pakistan interest rate. And we want to predict stock index price. Right? Here, how many features do we have? How many inputs do we have? 2 inputs, interest rate and unemployment rate. And what is the output? Stock index price. We can say, hang on. So these are the inputs. This is the gold label, the output. For inputs, we know the outputs. For these inputs, we know the outputs, and this is the training data. And this interest rate, unemployment rate, इसका नहीं पता हमें. So this could be the values for which we want to find output. Right? Let's mathematically formulate all this. We assume that we have D columns. We will always use D in this course to denote, to refer to the number of inputs or the number of features. In this example, we have 2 features and therefore D is equal to 2. Right? We use a vector xi to refer to the features of the ith sample. That is, so x has a vector, xi has D components. Right? First input, second input, third input, and dth input, dth feature. If yi is the label associated with the ith sample xi, so we formulate training data in pairs as xi, yi, right? Where xi is the input for the ith sample, yi is the output for the ith sample. And we use this n to denote the number of inputs we have. In this example, we have 21 inputs. Right? So summarize, we use D to denote the number of features. We use N to denote the number of samples. If X is a vector that stores, that contains all the possible inputs, so you expect X is a vector that would have D components, xi1, xi1, xi2, and xid. and yi is the output. अभी हम assume करेंगे कि yi है वो scalar है, एक ही output है सिर्फ. Questions, Zarsh, South?
Rwa के जो xi है, which is like the ith sample, is that the row? हम row की बात कर रहे हैं?
Very very good question, right? Yeah, this is I is equal to 1. This is I is equal to 2g. So I is moving towards rows, and this is first the D is moving here, right? So D means number of columns, -1, because the last column is the output. Munim, G.
Sir, since we have two features in this case, won't X have two components for each ith value? Since X is our features, it'll have two components, right?
Yes.
For each ith value.
Yes, yes. बिल्कुल सही है. So in this case, x1 would be a vector which has 2.75 as the first value and 5.3 as the second value, and y1 is 1464.
All right, got it. Thank you, sir.
Great. Okay, any questions, G?
Is it possible कि जो हमारी output है वो भी like a vector of 2 or more values?
G, we can have a vector output. Obviously, you can treat that as a multiple single output problems.
Makes
But
sense.
yeah, but most of the time in this course we will talk about single output. जब हम आगे जाके बात करेंगे SVM की या neural network की, there we will talk about multiple outputs. But most of the time we will talk about कि एक single output है, कि आपने एक single value predict करनी है, कि spam है कि non spam है, या age stock and price आपने estimate करनी है, एक ही output है सिर्फ, ठीक है?
Okay. चीज confirm कर ली.
जी मुझे पूछो.
The number of जो आपका I था, that was the number of samples you had for any data. ठीक है सर. बस मैंने ये पूछा था.
N is the number of samples and D is the number of features.
ठीक है सर. I किस चीज को pretty note कर रहा था?
दोबारा पूछें.
सर जो I था आपने mathematical notation में.
जी I is just an index. I is moving along. I is equal to 1 means first sample. So I moves from 1 to N.
ठीक है सर.
ठीक है बेटा. So using this formulation, we can define the entire training data using this notation, using set notation. D using a D symbol because D means data or dictionary or training data. Right? We can keep it simple. Right? Data. Right, and you stack all the inputs, n number of inputs and outputs in the form of a set, and this is your training data. This is the data you have, right? So here, what's the size of this data? So this data would be a subset of, right, this feature space xt times the output space y. So since the features can be categorical, आपके पास ये भी हो सकता है कि in the previous example, you add one feature के GDP grow कर रहा है कि नहीं कर रहा, yes or no. Right? So you can have, or 0 or 1. You can have a binary or a categorical variable, right? That's why we're not using this RD into R. अगर आपके पास inputs भी real numbers हैं, output real number है, तो we can say कि आपकी जो input space है वो RD times R से belong करती है, right? But in general we're saying this is a d-dimensional feature space जिससे आपकी input belong कर रही है, and one-dimensional output space जिससे आपका y belong कर रहा है, right? So yeah, this is a d-dimensional feature space and this is the label space of the output. So regression के अंदर the output space would be a real because we are predicting on a continuous scale. In classification, y क्या होगा? Y would be 0 or 1, or at times we call it -1 1 or 1 2, but it only contains two values. 0 1 या -1 1 या 1 2. If the problem is binary classification, if we have a M class classification, y can take any other discrete values 1 2 to M, or it could be letter grade A B C D or this is a 5 class classification. Question or hand raise, किसने किया था?
Sir, I was just thinking about how we would represent x1 if x1 itself is a vector. I studied it on. But, yeah, I get it now. Thank you.
अच्छा ठीक है बेटा, great. साउथ आपका क्वेश्चन बेटा? आपकी आवाज नहीं आ रही है।
क्वेश्चन हो गया सर।
ठीक है, ग्रेट। हनान?
सर मुझे वो समझ नहीं आया था, आपने जो बताया था r² × r वाला जो था वो हम यूज क्यों नहीं करते?
ओह या, बिकॉज अगर ये सारे x1 क्या है, x1 में क्या पड़ा होगा, राइट? लेट्स सपोज d is equal to 3 है. Let's take a previous example, right? d is equal to 2 है. So x1 contains, पहली वैल्यू क्या थी? I think interest rate, और दूसरी थी unemployment rate. Agree?
Yes,
in
sir.
this case, x1 belongs to R2. Right? But let us say I add another input and make d is equal to 3. And another input is political instability. So you have yes or no. Right? You have yes or no. Right? Now that variable is not in real space. So generalized, we call it, it's a d-dimensional feature space. That each feature can be a real number or it can be a categorical variable. ठीक है?
Thank you.
Great. Zain?
सर कैन आई स्प्लिट, जैसे x के 2 इनपुट्स हैं मेरे पास, तो कैन आई स्प्लिट द डेटा इन 2 डिफरेंट टाइप्स ऑफ डेटा सेट्स, यानी कि x1 का मतलब 1-to-1 मैपिंग कर लूं मैं, जो 2 इनपुट्स हैं उस पे 2 मॉडल्स बना लूं, वो लाइक मल्टी डायमेंशनल लेबल्स बना के उसको उस तरह से कर लूं, वो फर्क होगा?
सॉरी, दोबारा बताइए।
So जैसे आपके पास यहाँ पर जो x inputs हैं, you have 2 labels, right? And those 2 labels map to 1 output. So what if I split the data set के जो according to the labels, यानी कि जो एक label है वो फिर map कर रहा है उसके ऊपर, if you are getting what I mean. मतलब सर जो आपके labels हैं वो दो quantities हैं जो कि एक output को map कर रही है ना, 2 to 1 हो रहा है, तो अगर मैं उसको 1 to 1 के 2 बना लूं फिर?
फंडामेंटली गलत बात है। हाँ, आपके लेबल 2 नहीं है, इनपुट्स 2 हैं। फर्स्ट करेक्शन, लेबल आपका एक ही है, राइट? सो यू आर सेइंग f of x is a combination of is a function of, right, a1 x. अगर x1 x2 दोनों इंडिपेंडेंट हैं तब तो ये आप कर सकते हैं। सो you are assuming that there is no relationship between inputs.
That's fundamentally wrong. ठीक है सर, ठीक है, I get your point.
These all are idea ये कि they all interact with each other. आप उन सबको manipulate करते हैं, multiply करें, add करें, subtract करें, किसी का exponential लें, किसी का sinusoidal लें, and किसी को non-linearity से गुजारें, and then you all combine these inputs and get an output. Right? The idea is to find the underlying relationship between inputs. ठीक है? ओके। साउथ?
सर जो हमारा इनपुट्स होते हैं, डू दे हैव टू बी ऑफ द सेम डेटा टाइप, या फिर कैन बी लाइक एक इनपुट इज न्यूमेरिकल या कोई दूसरा इज कैटेगोरिकल?
जी बिल्कुल
हो सकता है,
बिल्कुल हो सकता है, बिल्कुल हो सकता है।
तो फिर इनपुट की स्पेस चेंज नहीं हो जाएगी? लाइक हाउ विल वी क्वांटिफाई, लाइक xd किस तरह क्वांटिफाई करेंगे?
हाँ, मैंने इसलिए कहा कि xd जो है वो जनरलाइज्ड स्पेस है, उसको मैंने रियल नंबर से रियल स्पेस नहीं कहा है। That's why I'm using this xd, right? This is not x, by the way. This is a Greek symbol psi. जी, but yeah, you can have a mix of categorical variables and real values. ठीक है?
सर अगर हमारे पास जो आउटपुट है वो मुझे ये भी बताती है कि जो जेंडर है वो मेल है या फीमेल है, और साथ उसकी एज भी प्रेडिक्ट करती है, तो फिर तो वहाँ पर रिलेशन भी हो रही होगी, क्लासिफिकेशन भी हो रही होगी ना?
हाँ, ये तो 2 आउटपुट्स हैं ना, तो आपके पास 2 प्रॉब्लम्स हैं।
ठीक है, अलग अलग सही, makes sense.
Okay, let's talk about some examples, right? Just to clarify all of this. So, for example, we have a machine learning problem in which you want to build a model that takes all these inputs and predict oxygen saturation. Okay. What is D here? So 1, 2, 3, 4, 5, 6, 7, 8. So D is 8, right? And output is 1. What is N here? 200. Okay. Say we are using MNIST data. You want to build a model that takes an image and predict के उस पे handwritten में क्या लिखा हुआ है, numerical value, right? And what is D here?
So 25.
28.
So 9 है, नहीं 10 है, 0 to 10.
3 to 28.
D था क्या? Number of features, right?
10 है ना?
Number of features 10 नहीं है.
So 25.
And this is a classification regression.
The classification.
Multi-class single binary classification.
Multi-class classification.
Multi-class. So M is 10, right? So it's a 10 class classification. 0 to 9 कुछ भी हो सकता है value, right? Done. What is D here? D is the number of inputs. 28 times 28, 784 have pixels, right? So we have 784 inputs. And what is N? 60,000.
सर हम 784 को 25 से मल्टीप्लाई नहीं करेंगे, because that's for हमारे पास टोटल 25 images है.
नहीं हमारे पास टोटल 60,000 है. सिर्फ एक स्नैपशॉट दी है मैंने 6,000 की, सिर्फ स्नैपशॉट ऑफ देखते हैं. जी जी
ठीक है.
बट अ मॉडल की इनपुट क्या है? मॉडल का यूज करेंगे फ्यूचर में. मॉडल की जो इनपुट है दैट इज a single image. For example, this image goes an input and output is 9. Right? You can say the output set y जो है वो इस तरह का है 0, 1, 2, 3, 9. और आपकी जो input space है जो हम psi d का था, that contains 784. Each x is a 784. A vector of 784 values, and those values could be if you're using 0 to 1 scaling for grayscale images, or if you're using 8-bit coding, so you can use 1 to 255 values. So 0 to 255 values हो सकती हैं. Okay, but D is 784. ठीक है जी. Okay, we have talked about nomenclature. Let's talk about the concept. What do we mean by learning? What's the notion of learning? Right. So recall a problem in hand. We want to develop a model. We want to learn a model that can predict the label for the input for which the label is unknown. We assume that these data points, input output are drawn from some unknown distribution, a joint distribution probability of xy. ये अभी क्लियर हो जाएगा सब कुछ, आप बेफिक्र रहें, घबराना नहीं है आपने. So our goal is to learn the machine, जिसको हम मॉडल भी कहते हैं, जिसको हम फंक्शन भी कहते हैं, जिसको हम शायद हाइपोथेसिस भी कभी कहेंगे, such that for a new pair XY that is drawn from this joint distribution, we can use this H to obtain the actual output or an approximated version of the output Y in some optimal sense, right? कि हमें अगर मैं सारे को summarize करूं बहुत आसान अल्फाज के अंदर, right? So we want to find, ये वही बात है, हम इसको हम पहले F कह रहे थे, हम इसको H कह रहे हैं. We want to find H of X that gives us Y, and this, okay. We want to find H of X that gives us the output which is close to Y as much as possible. And when I say close to Y, it means, when I'm saying as much as possible, we should define a way to quantify this closeness. कि हम closeness को define कैसे करते हैं? And that's why when I'm saying in some optimal sense, for example, हम कहते हैं कि distance minimize हो जाए, right? And that distance could be an Euclidean distance. That distance could be Manhattan distance. Distances can be made in different ways, right? And when we define closeness, it depends कि आप distance कैसे measure कर रहे हैं, right? So in some optimal sense, it's the generalized notion, close to Y as much as possible is what we want, right? In the previous example, so the label was stock price index that we wish to estimate using unemployment rate and interest rate, right? The training data is drawn from some distribution. So for example, if you get the data for US market and try to carry out inference on Pakistani data, we should not be expecting the model to work. Agree? So data is drawn from some unknown distribution, and this HFX is trying to model that distribution, is trying to capture the unknown relationship between X and Y, input and output, governed by this distribution. This H could be an artificial neural network. This H could be a simple regression model. This H could be a decision tree. We call the set of possible functions as hypothesis class. So देखें ना, जो H है, H एक linear regression model भी हो सकता है, एक neural network भी हो सकता है, एक decision tree भी हो सकता है, right? So these are all the class of functions, right? And we can say H belongs to hypothesis class. So, and we denote this hypothesis class by this H. For a given problem, we wish to select hypothesis function, a model from the hypothesis class. The question is, how do you select? So we define hypothesis class for a given learning problem. आपने कह दिया कि for some problem you have a model could be linear, a model could be neural network, or model could be a tree, decision tree. So you have this class of hypothesis function, and from this class you want to pick one, the best one. So we evaluate the performance of each candidate function in this class and choose the best one. And this is where, when you say evaluate the performance and choose the best one, this is where the loss function or the risk function or cost function or objective function comes in. So a loss function evaluates a given hypothesis on our training data and tells us how good it is or how bad it is. ठीक है जी? So how do you evaluate the performance? Define the loss function to quantify the accuracy of the prediction. A loss function is, it's quantify the error in predicting Y is using hypothesis function H and input. So the higher the loss, the worse the model is. So a loss of 0 means your hypothesis function is making perfect predictions. ideally we require loss to be 0. That is only possible if we can find the exact hypothesis that defines the relationship between x and output. So we will use this L to denote the loss function. Let's talk about different loss functions. I think Zarsh asked question about types of loss functions we can have. Right? We start with 0-1 loss. Right? So as the name suggests, 0-1 loss is simply कि एरर है या नहीं है, कि आउटपुट इनपुट के बराबर है, सॉरी आउटपुट ट्रू लेवल के बराबर है या नहीं है. दैट इज 0-1 लॉस. लग रहा है मैथमेटिकली बहुत कॉम्प्लिकेटेड है ये, बट लेट मी एक्सप्लेन दिस. बहुत आसान हो जाएगा अभी ये. ठीक है. ओके, आई एम यूजिंग दिस नोटेशन डेल्टा. व्हाट इज दिस डेल्टा? दिस डेल्टा इज नोन एज क्रोनेकर डेल्टा. इट मीन्स इसका जो आर्गुमेंट है जो यहाँ पे नीचे आ रहा है सबस्क्रिप्ट के अंदर, इफ दिस इज zero, this delta gives you 1. If this subscript is not equal to 0, you get 0. ठीक है. ओके, हम इसको हम यूज करते हैं लॉस फंक्शन के डेफिनेशन के अंदर. लेट अस सपोज, ओके, आपके पास है क्या यहाँ पे? आपके पास डेल्टा है, h ऑफ x i है माइनस y i है. ये क्वांटिटी क्या बता रही है आपको? सबस्क्रिप्ट के अंदर लिखी हुई है जो. सो दिस क्वांटिटी इज
एरर बता रही है.
एरर, राइट? h of x i, what is predicted by your hypothesis h, and yi actual label, the error. अगर एरर 0 है तो डेल्टा की वैल्यू क्या होगी? ये किसी i के लिए अगर एरर 0 है तो ये वैल्यू 1 होगी. और 1 माइनस 1 क्या हो जाएगा? 0. राइट? इट मीन्स कि किसी i के लिए अगर आपका मॉडल बिल्कुल सही आउटपुट कर रहा है तो ये क्वांटिटी पूरी उस i के लिए 0 होगी. एग्री? देयर इज अ पॉसिबिलिटी कि आप में से कुछ लोगों को लग रहा हो कि नोटेशन बहुत कॉम्प्लिकेटेड है, लेकिन इसको अगर आप थोड़ा जूम इन करें, थोड़ा समझने की कोशिश करनी, बहुत ईजी है. सो दिस क्वांटिटी जो मैंने अभी इंसर्कल की है, सो इट डिपेंड्स ऑन i, राइट? सो दिस वुड बी 0 if no error, and this would be 1 if there's an error between prediction and output. That's why we call it 0-1 loss. Right? And then we do this for every input, and we sum the errors for all inputs and divide by the number of inputs. Right? अगर मैं इसको इंटरप्रेट करें, right? This is a loss on average, right? So we're normalizing by n to make it per sample, right? इसकी इंटरप्रिटेशन मैंने लिखी हुई है. So loss function simply counts, जो summation के अंदर है, we are simply counting the number of mistakes, number of errors made by hypothesis function on the data, so on D, and we simply divide by 1 over n to make it the loss, to make it per sample loss. ये क्लियर हो गया? नहीं हुआ? or do you want me to repeat it?
एक्सक्यूज मी सर. सो इस फंक्शन की आउटपुट 0 या 1 ही होगी ना एसेंशियली? तो
किस फंक्शन की?
ये जो ऊपर लिखा हुआ है,
नहीं,
जो लॉस फंक्शन डिफाइन हुआ,
जो समेशन के अंदर है वो 1-0 होगा, राइट?
नहीं सर, अगर हमारे पास लाइक लेट्स से वी हैव एन एरर, तो जो समेशन है दैट, वो जो समेशन है i is equal to 1 to n for 1 will be n, तो फिर 1 over n into n will be 1, तो लाइक द आउटपुट तो हमेशा काउंट कैसे करेगा ये?
जी जी, जो समेशन के अंदर है वो काउंट कर रहा है, राइट? इट काउंट्स द नंबर ऑफ मिस्टेक्स ऑन एवरेज, लेट सपोज लेट मी टेल यू, राइट? सो आप n इज इक्वल टू 1000 था और मॉडल ने 100 आउट ऑफ 1000 सैंपल्स में मिस्टेक किया। इट मींस आपका समेशन के अंदर जो वैल्यू आएगी उसका सम 100 आ जाएगा, and you divide by 1000, it means 10% or 0.1 is your 0-1 loss. जी हमजा, it will be between 0 and 1 obviously. Maximum अगर सारे सब में mistake कर रहा है, 1 means it's mistakes everywhere, right? And the 0-1 loss function, we use it to evaluate classifiers mostly, but most of the times we don't use it because there are issues with this for some reason. Because of the non-differentiability, this loss function is not differentiable, and this is also a non-continuous भी नहीं है ये. Just a minute, my pen is not working for some reason. जी बताइए, क्वेश्चंस?
सर कोई क्वेश्चन, समेशन के अंदर आपने जो कहा है 0 इफ नो एरर, इसको एक दफा दोबारा एक्सप्लेन कर सकते हैं? क्योंकि जहाँ तक मुझे समझ आया कि डेल्टा जो है हमारे पास प्रेडिक्टेड आया और हमने उसको सब्ट्रैक्ट कर दिया जो एक्चुअल रिजल्ट है। अगर हमारे पास जो एक्चुअल रिजल्ट है उसके इक्वली आया तो वो हमारे पास 0 नहीं होना चाहिए?
जी, वो 0 आ गया ना। इट मींस आपके पास जो डेल्टा के पास सबस्क्रिप्ट में आ रहा है वो 0 हो गया। एग्री?
एग्री।
आप डेल्टा की वैल्यू, डेल्टा को देखें, डेल्टा क्या देगा आपको? जब डेल्टा का सबस्क्रिप्ट 0 है तो डेल्टा गिव्स यू 1।
ओह राइट,
ठीक हो गया? देखिए आपने खुद ही आंसर किया। ग्रेट
सर।
जी साउथ,
can you explain normalization? You mentioned that.
जी जी, normalization is used for example, so you have 1000 data points and your friend has 1500 data points, right? और आप दोनों एक मॉडल का 0-1 लॉस निकाल रहे हैं, right? You should be looking for the loss per sample, या ऑन एवरेज लॉस कितना आ रहा है, right? So क्योंकि दोनों के डेटा साइज का डिफरेंस है तो इसलिए अगर आपके फ्रेंड के पास ज़्यादा डेटा पॉइंट्स हैं और इसका लॉस ज़्यादा आ रहा है, डजंट मीन कि वो मॉडल बुरा है। That's why we use 1/n. We normalize by the number of samples.
Okay.
ठीक है। जी, और क्वेश्चंस? हनान जी।
जी सर, ये नॉन डिफरेंशिएबिलिटी का क्या मतलब है?
Oh, this is not differentiable because so we can, since because of delta function is basically it's a step function, right? It means कि आपका इसका जो आर्गुमेंट है जो इसके सबस्क्रिप्ट में लिखा हुआ है, that can have any value, right? अगर वो 0.1 है, 0.2 है, 0.3 है, सबके लिए डेल्टा वो है 0 देगा। So if you want to find the hypothesis and you want to differentiate with respect to some parameters of hypothesis function, आप उसको differentiate नहीं कर सकते हैं। डेल्टा फंक्शन जो है वो inherently एक तरह से सिर्फ उसका सबस्क्रिप्ट है, जब 0 होगा तब 1 देगा, अदरवाइज बाकी वो 0 देगा। इट मींस वो नॉन डिफरेंशिएबल है।
सही है सर, थैंक यू।
ठीक है बेटा, ओके। जैन आपका क्वेश्चन बेटा?
सर वो हैंड रेज हुआ था, माय अपॉलॉजीज।
अच्छा ठीक है, चलें आगे चलते हैं जी। ओके, जस्ट मुझे 5 मिनट दे दें, हम लॉस फंक्शन फिनिश कर लेते हैं, बाकी फिर कंटिन्यू करेंगे आगे, ठीक है? So squared loss, as the name suggests, we square the error and we sum over all inputs and we divide by number of inputs. It is, we call it mean square error. ठीक है, क्योंकि अगर नाम देखें इसका मीन स्क्वायर का मतलब ये है कि you square first and you take a mean. आपने स्क्वायर लिया, सम किया, डिवाइड बाय नंबर ऑफ पॉइंट्स किया, that's we call it mean square error. This is we use this very frequently. So loss grows quadratically with the absolute error amount in each sample. जो स्क्वायर है, स्क्वायर ऑपरेशन है, वो लॉस अगर डिफरेंस नेगेटिव है पॉजिटिव है, the square operation would make it positive. Very often we hear RMSE or root mean square error, right? RMSE is just square root of squared loss function. If you see, आपको से नाम मैं बता दूं कि RMSE क्या होता है, right? So you don't need to remember this कि ये mathematically क्या है. So RMSE itself explains everything, right? So it's squared first, you take a mean, and then you take a square root. So ये square हो रहा है, summation or divide by number of samples is taking like mean, and square root is root square. So RMSE is squared mean square root. Okay, another loss function is absolute loss function. As the name suggests, instead of taking a square, you take absolute and you take a mean, right? This is also known as, in fact, the better term is mean MAE, mean absolute error. So जब programming करेंगे आप लोग तो you will encounter this MAE. MAE क्या होता है? Nothing but this is just a mean absolute error. Obviously all the losses are non-negative. ठीक है? So हम यहाँ पे stop करते हैं, or in the next lecture, I think we should meet on Tuesday because I want to cover this, finish this supervised learning setup. Say we meet on Tuesday for half an hour to cover the content. ठीक है जी. Okay, we stop here, and then we'll build on these concepts in the next lecture, inshallah. Any questions? I'm around.
सर पहले असाइनमेंट कब रिलीज होगी?
1 से 2 दिन के अंदर. सैटरडे को मैं रिलीज कर दूंगा. द फर्स्ट इज प्रोग्रामिंग असाइनमेंट, जो कि पाइथन का इंट्रोडक्शन है, कोल ऐप के ऊपर आप सेटअप कैसे करते हैं वो है. We will also release a pre-lab tutorial as well. Right? So we are making a pre-lab tutorial because we know that there are some students who will be exposed to Python for the first time, Colab for the first time, and to facilitate those students, we will have this pre-lab tutorial session.
Right. Thank you.
ठीक है बेटा. So let me stop.